Well, here we are again. Unit conversions. Now, we've already done some unit conversions. Yesterday, we did conversions from one metric prefix to another. Today, we're going to expand on that and do several other types of unit conversions. A couple of objectives here today. First of all, I want you to be able to write conversion facts as unit fractions. We're going to focus today primarily on the unit fraction conversion method. Any conversion facts can be written as unit fraction. We'll see what that is. I'd like you to be able to convert units of any type. That could be a distance, a mass, a volume, an area, a rate, a current, a force, a pressure, and be able to convert them to any other units that measure the same type of quantity using the unit fraction conversion method. Oops. Oh, that's it. Thought there was a third one there. Those are the two things we want to accomplish today. The first thing we have to agree on is what exactly is a unit fraction. Well, 1 foot is equal to what? Everybody knows that. 1 foot is equal to 12 inches. That means that you can write, if you have an equivalency, a conversion fact, you can put one half of the conversion fact, it doesn't matter which one, on the top of a fraction, the other half on the bottom, and the numerator and denominator will be equal. And don't you agree that if those two quantities are in fact equal, and then you go and put one of them over the other one, wouldn't you agree that that fraction has to be equal to 1? Sure it does. Has to be equal to 1. And it's still equal to 1 even if you write them in reverse order. 12 inches over 1 foot. That's still true. That means that if you have a quantity and you multiply it by 1, or this, it doesn't change the quantity. Well, that's the basis for the unit fraction conversion method. What you do when you're writing that, when you come up with one of those fractions, that's called a unit fraction, and every conversion fact can be written in that way. But here's the punchline. If you take a measurement and multiply it by the unit fraction, it doesn't change the value. All it does is change the units. And the reason is because units cancel just like common factors. Now, how many of you have had physics before? Have you taken a physics class? If you've taken a physics class, you've seen a lot of this. Okay? The way that units will cancel with each other just like they were numbers. Now, the easiest way to see this is just by a good old example. So let's take a look at this example. Notice that this is a regular equal sign and not a little squiggly equal sign. That means this is an exact conversion. We'll see why that's important a little bit later. But here's what we're going to do. The first step in performing conversions in this method is to take the value you want to convert and slap it over 1. Turn it into a fraction by putting it over 1. So we're going to have 15,400 feet. And we turn it into a fraction by putting it over 1. Now, we're going to multiply that by a unit fraction. And that unit fraction is either going to be one of two things. It's either going to be 5,280 feet over 1 mile, or it's going to be 1 mile over 5,280 feet. Now, what units do we want to get rid of here? Feet. So we want them to cancel off. There is a feet in the numerator. If we want it to cancel, where is the feet going to have to go in our conversion fraction? It's going to have in the denominator. So we're going to have feet in the bottom, which means miles is going to have to be on the top. So apparently, 1 mile equals 5,280 feet. That's the way that our fraction is going to have to be arranged. Now, we can go ahead and multiply that out. Feet will cancel. And we multiply 15,400 times 1. That gives us 15,400. The only units left in the numerator are miles divided by 1 times 5,280. And we're going to divide that out. Now when we divide that out, the question is, how many significant digits can we keep? We're going to go back here. How many did we start with? 3. The conversion fact was an exact conversion fact. In other words, there's no error introduced by this. There's exactly 5,280 feet in a mile. So all we pay attention to is the number of sig digs here. There was 3 to start with. We're going to have to finish with 3. And so we would call this you have 2.916666 when you divide this last step. Then you're going to round that to 2.92 miles. 2.92 miles. Did you get the same thing? 2.92 miles. There's 3 sig digs. We're done. That's the principle that everything we're going to do today is based on, but we're going to look at all the different types of conversions that can surface, because there's probably about a half a different circumstances that can arise. That's about the simplest case. Let's take a look at another one. Let's convert 7.5 pounds to ounces. All right, 7.5 pounds into ounces. 1 pound is 16 ounces. What units have to go on the bottom here? Pounds. So 1 pound is equal to 16 ounces. Now, stop for a minute. I want to show you by far what the most common mistake I see in these conversion factors is. And it's going to, when you look at this, you're going to think, why would anybody make that mistake? It's a good question, but it happens all the time. It's this. I'm going to do it in red, make it stand out. It's very rare that you'll put the units in the wrong spot, okay? Because we recognize they need to cancel, but this is the mistake. People will spend a lot of time making sure the units go in the right spot and then get careless about putting the numbers in the right spot. And they'll say 16 pounds and 1 ounce. But is 16 pounds equal to 1 ounce? No, this fraction is not equal to 1. It's not a valid unit fraction and won't work to do the conversion. So be careful choosing the location of your units, but then make sure that you associate the units with the number pound. That's 1 pound and 16 ounces. Now, your units cancel, and you can proceed. 7.5 times 16. What's 7.5 times 16? Anybody got that worked out? What is it? 120. The only units left up there are ounces. And on the bottom, the units cancel, and we're left with a 1. And so our answer is 120 ounces. How to handle the sig digs. Mentioned this earlier. The lowest number of significant digits, either in the original value or any of the conversion factors that aren't exact, limit the number of sig digs in your result. So, go back to this example we just did. You started out, you've got 2 sig digs here. Is this conversion factor exact or not? It is exact, and so it does not play into how many sig digs your result can have. So we're limited to 2, 120 ounces. What that means is conversion factors should be chosen if you have a choice of more than one. They should always be chosen so that they are either exact or contain more sig digs than your original measurement, so that your conversion factor doesn't limit the accuracy of your result. If you've got a very accurate beginning value and then you use a poor conversion factor, doesn't it make sense that that's going to ruin the accuracy of your measurement? Sure it does. So you have to make sure that your conversion factor has at least as much accuracy as your original value. Sometimes you can't, but you try. Okay, well, let's take a look at a couple more and pay a little bit more attention to that. 6.550 feet. I'm going to put that over 1. Okay, well, we can't get there in one step. There is no conversion on your sheet from feet to centimeters. Now, certainly some conversion fact exists, but we don't have it handy. So we're going to use a couple of steps. What do you want to go to first? Let's go to inches. But don't stop and figure out how many inches it is. We're just going to run all these conversion facts together. So we're going to get rid of 1 foot down here, make the units cancel, and we're going to go to inches. That's 12 inches. Don't stop and compute that. Keep right on going. That'll cancel out your feet, but now we need another conversion fact that'll cancel off the inches and go to centimeters. 2.54 centimeters over 1 inch. Okay, we're going to multiply that out. 6.550 times 12 times 2.54 for the numerator. I'll keep extra sig digs here and then we'll cut it off when we're done. 199.644. Those are centimeters, and that's all over 1. Now, go back to the beginning. Sig digs in our original value. There's 4 here. Here, it's exact, so we don't care. There's no error being introduced here, so that's okay. This one, exact, so we don't care. And so we're limited to 4. We have to call this 199.6 centimeters. You need to know that there is 12 inches in a foot. You need to know that there are 4 quarts in a gallon. You need to know that there are 2,000 pounds in a ton, that there are 16 ounces in a pound, and that there are 3 feet in a yard. You'll be expected to know those 3 facts. In addition to that, you do need to know the metric prefixes. Okay? That's from yesterday. That goes without saying that you need to know the metric prefixes because those provide you with more conversion facts. Okay. Well, areas and volumes are a special circumstance that we need to pay attention to. Areas and volumes often contain exponents. For example, if we were to measure the area of the carpet in this room, it would be in yards squared, or square yards. If we were to measure how much air is in this room for the purposes of heating it, for example, we'd want to know how many cubic feet or feet cubed. That requires a special process when you're performing a conversion. That is, the conversion process has to reflect the fact that those units are not straight up units, but in fact squared or cubed. Problem is, we want to convert 55.0 centimeters cubed to cubic inches. We start out with the setup the same way, 55.0 cubic centimeters over 1. Now, here's the kicker. We want to convert centimeters to inches, cubic specifically, but you go to your conversion sheet. Do we have a conversion fact? Yeah, we don't have a conversion from cubic centimeters to cubic inches. Doesn't mean it doesn't exist, because it does. We just don't have access to it. So we're going to use the conversion from centimeters to inches, but we need to make sure that it is cubed. So what we're going to do is put parentheses around this conversion fact. We want to get rid of centimeters. We want to go to inches. 1 inch is 2.54 centimeters. But what do you suppose we need to do with that conversion? We need to cube it. That means that these centimeters times centimeters times centimeter in our original value will cancel with centimeters times centimeters times centimeter in the denominator here, and we'll be left with inches times inches times inches, or cubic inches. Now, when you're multiplying that across, you need to make sure not to miss that exponent when you multiply by the conversion fact. So the numerator is no trouble. We'll take 55 times 1 times 1 times 1, or 1 cubed. So what do you end up with in the numerator? 55, yeah. Your units up here are now inches cubed. Now the denominator, we've got 1 times 2.54 times 2.54 times 2.54. In other words, 1 times 2.54 cubed. So 2.54 cubed. Should be able to do that on your calculator pretty quickly. And 16 point. Now, you got to be careful with this and make sure to leave plenty of extra digits, because is this an exact or approximate conversion factor? This one's exact. It would be a shame to round it off and turn it into an approximate conversion factor. So how many sig digs are we going to be allowed to have? We're going to be allowed to have 3. You better leave at least more than 3 down here so that that conversion fact doesn't introduce error. So we'll just leave a few. 3, 8, 7 is good enough. Again, as we saw a couple of frames ago, it has to be just more than how many we have in our beginning value so that it doesn't introduce new error. So we have 55.0 inches cubed over 16.387. We're allowed to keep 3 significant digits. And what'd you come up with 3 sig digs? 3.36. And those are inches cubed, 3.36 cubic inches, and we converted the volume. Okay. Well, I'm going to give you this one for practice. Just take a minute, see what you can do with it. We'll go through it together in a minute. I'd like you to convert 8.39 times 10 to the 8th square inches to square meters. Well, let's have a look. We got square inches right now. Do you suppose he'd let me answer it? Okay, let's take a look at it. We want to convert those square inches into what? Centimeters. So we got inches on the bottom. We're going to go to centimeters on the top. 1 inch, 2.54 centimeters, but we're going to have to take that conversion and square it. That'll get rid of the square inches, but we can't quit there. We still need to go to square meters. So you can think of this conversion a couple of different ways. We need to put centimeters down on the bottom, and we need to put meters on the top. What numbers do you fill in there? There's 2 different ways you could answer this. You could say 100 centimeters in a meter, right? Okay. That's the way that we'll do this one right now. 10 squared would work. And we need to square that. That's how we'll answer it for now. I'm going to show you another way in a couple of examples in a similar problem. But that's the easiest way to do it now. Centa, just like cents in a dollar, there's 100 cents in a dollar, there's 100 centimeters in a meter. So now that cancels off the centimeters, and we can go ahead and multiply across. Now, going to need to use the exponent key on your calculator to work this out. 8.39 times 10 to the 8th times 2.54 squared. And how many sig digs here? 3 here. It's exact, so we don't care. This one is exact, so we can keep 3 on here. When you multiply that out in your calculator, you should get 5.41 times 10 to the You should get 5.41 times 10 to the 9th, and those are squared meters. Now, what have you got in the denominator? You've got 1 times 1 times 1 times 100 squared. What do you have down here? 10,000, 100 times 100. And so now we can divide that. 5.41 times 10 to the 9th divided by 10,000, that's the same as 10 to the 4th, and we end up with 5.41 times 10 to the 5th square meters. And we're done. If that one gave you trouble, it's more than likely because of the power of 10. Make a note of that, and we'll take a look at how you're doing it on your calculator right after class and make sure that if there's a problem with that, we get it cleared up. 5.41 times 10 to the 5th meters squared, 3 sig digs. Okay, well, there's two more types of conversions that we can stumble across. Rate is the first of the remaining two kinds. A unit rate is a type of unit that has more than one unit in it. Now, you know some of these. Miles per hour is a good example. If you drive 65 miles per hour, you've got two units mixed in there, miles and hours. Okay? Whatever you make at work, how many dollars per hour? Dollars is one unit, hours is another. Anytime you've got a unit rate, you need to make sure that you convert all of the units and not just some of them. And you need to make sure that they all cancel properly. So let's take a look at an example of a rate and how it will be converted. Now, from math that you've had in the past, anybody remember what the word per means in math? Division. So when you hear 55 miles per hour, that means it's miles divided by hours. Or dollars per hour, it's dollars divided by hours. So when you stumble across the word per, treat that as a division sign. So we want to convert 55 miles per hour to feet per minute. The only thing you have to be careful of here when you set it up is that hours is going to have to go in the bottom of our fraction because it's miles divided by hours, or miles per hour. So we keep the miles, but then we have our division sign and the hours gets thrown in the bottom. Look all right? We want to end up with feet per minute. Feet on the top and minutes on the bottom. So we have two things to convert. We're going to do it all in one shot. You only do one at a time, though. Let's start with the miles to feet, the top unit. So we want to get rid of miles, and we're going to go to feet. 5,280 feet in 1 mile. Now, if we cancel off miles, and we were to stop right there, because there's a Seinfeld rerun on, and we don't want to finish the problem. We're just going to stop right now. What units would you have if you had to quit right now? You'd have feet per hour. Okay, so we're halfway there. But we don't want to quit there. Now we want to get rid of the hours and make it feet per minute. So where is the hours going to have to go in this next conversion? It's going to have to go on the top. 60 minutes. In 1 hour. I suppose I could say that that's another conversion fact that you just have to know. But 24 hours in a day, 7 days in a week. Hours now cancels, and now your units that you're left with will be feet per minute. That's just what we want. So once you've got the units set up, we just proceed as we did before. 55.0 times 5,280 times 1. In the top, we get 290,400. In the bottom, we have 1 times 1 times 60. That's 60. The top units are feet. The bottom units are minutes. And when you divide that out, how many sig digs will we be able to keep in our answer? 3, exactly. We started with 3. That one's exact. This one's exact. And so we can keep 3. And your result should work out too. Anybody have it? 48, 40. And the units are feet per minute. Good. And one more rate before we wrap it up here. Let's convert 2.55 times 10 to the third pounds per square inch to newtons per square meter. All right, well, let's take care of the pounds to newtons first. Let's put pounds down below, newtons up above so that pounds cancels your conversion fact here. This is on your sheet, and that is 1 pound is 4.45 newtons. That cancels off the pounds. If we were to stop there, our result would be in newtons per square inch. So we got to keep going. We want to get rid of the square inches. We want to go to square meters, which we can't do directly unless you know how many inches enter a meter, which you could figure out, but I don't know it. So we're going to go from inches to centimeters. And we have to square that conversion since they're squared units. That'll cancel off the square inches. Now if we were to quit there, we'd have newtons per square centimeter. Still not done. Get rid of centimeters by putting it in the numerator of our final fact. Meters will go on the bottom, which is what we want. 1 meter is in fact 100 centimeters, and we need to square that one. That'll cancel off the centimeters, and that'll leave us with newtons over meters squared. Setup look okay? Okay, start multiplying. 2.55 times 10 to the third. Now you really could call that 2,550. Wouldn't matter. Now it's good to leave extra sig digs and round off when we do that last division step. So I'm going to leave plenty of extra sig digs here in our numerator. Did anybody else get the same thing in the top half of this fraction? Okay, good. The bottom half, that's not quite as tricky here. 1 times 1 times 2.54 squared times 1 squared. That turns out to be 6.4516. And those units down below are meters squared. And now we can divide, keeping how many sig digs? Started out with 3. That's approximate, but it's still 3. That one's exact and this one's exact, so we can keep 3. Dividing that, whoops, not 1.75. 1.76 times 10 to the what? 7th. Yep, 10 to the 7th newtons per square meter. We started out with our original value, pounds per square inch. We wanted to get rid of pounds and go to newtons. That takes care of that. Then we need to get rid of the square inches. The only thing we can really go to are square centimeters because that's the only good conversion fact we have. And then from there, we'll go from centimeters to meters squared. Multiply them all out, making sure to square these two conversion facts. That's what we end up with. And when we divide, we've got newtons per square meter. All right? Okay. Well, the last scenario is this. This is not something you'll have to know. Okay? You have to be able to perform the metric prefix conversions somehow. The way that we did yesterday is the best way. But you can do it using this method also. This is not an efficient way to do it, though, because it's a lot more writing to get the same result. But I want to show you one example of how you can do it. Let's convert 3.7 times 10 to the 8th milliamps to megaamps. We'll use this method instead of the one that we did yesterday. 3.7 times 10 to the 8th, these are milliamps over 1. Okay, so what units do we want to get rid of? We want to get rid of milliamps. The key to doing this using this method is that you don't have to do it this way, but it's the easiest way to keep it straight. You could go straight to megaamps, but the easiest way is to say, all right, well, let's just get rid of the base unit first. Let's just go from milliamps to amps. All right, that'll make the milliamps cancel. Now, 1 milliamp, what does milli mean? Yeah, thousandths. So 1 milli is 10 to the what? What does milli mean? Negative third. 1 milli is 10 to the negative third amps. Okay, so now if we cancel that out, we'll be in amps. Now let's keep going. What Ryan asked was, could we put 1 amp as 1,000 milliamps? And the answer is yes, you could. The reason I wrote it like this is because if you memorize the prefix meanings, which you should have, you can just say that 1 milli means 10 to the negative third of whatever our base unit is. Okay? All right, now we just need to go from amps to megaamps. And 1 mega means 10 to the what? 10 to the 6th. And now we can multiply. Amps now cancels. So what we get is 3.7 times 10 to the 8th times 10 to the negative third. Here we're back to the properties of exponents. What's 10 to the 8th times 10 to the negative third? Yes, 10 to the 5th megaamps over 10 to the 6th. Now, again, properties of exponents, what happens when you take 10 to the 5th and divide it by 10 to the 6th? You subtract, and so our answer is 3.7 times 10 to the negative 1 megaamps, and we're done. It's in scientific notation. That's the exact same result you would have gotten if I'd have given you that problem yesterday and we would have solved it like we did yesterday, whichever method you prefer. But you can see this is an awful lot of writing to do that conversion. So this is not the most efficient way, but it works. Okay, that's where we're going to stop.